Think about this for a second. Every single day, thousands of rivers around the world pour billions of gallons of fresh water into the ocean. Rivers like the Amazon, the Nile, and the Mississippi flow continuously. Yet the ocean never turns fresh. In fact, it stays intensely salty, with about 3.5% dissolved salts by weight. So, where is all this salt actually coming from? The answer is fascinating. The very rivers carrying fresh water are also one of the biggest reasons the oceans became salty over billions of years. It all starts high up in the sky with rainwater. Rain isn't just pure water. As water droplets fall through the atmosphere, they absorb small amounts of carbon dioxide from the air. This forms a weak acid called carbonic acid. It is far too weak to harm your skin, but over millions of years, it is strong enough to slowly weather rocks on land. Rocks contain many different minerals. As rainwater slowly breaks these rocks down, it carries dissolved ions such as sodium, calcium, potassium, and magnesium into nearby streams and rivers. Chloride also enters the oceans through natural sources such as volcanic gases and hydrothermal vents beneath the seafloor. When sodium and chloride eventually meet in seawater, they become the main ingredients of common table salt. River water does contain dissolved salts, but in extremely low concentrations. You can't taste them, but they're definitely there. So, if rivers carry dissolved minerals into the ocean, why doesn't river water taste salty while ocean water does? The secret is a process called the evaporation trap. When river water reaches the sea, the sun heats the ocean's surface, causing pure water to evaporate into the atmosphere and eventually form clouds. But while the water leaves, nearly all of the dissolved salts remain behind. Imagine adding a pinch of salt to a mug of water and leaving it under the sun. Eventually, the water evaporates, leaving the salt behind. The same thing has been happening to Earth's oceans for billions of years. Day after day, year after year, rivers deliver tiny amounts of dissolved minerals to the sea. Water evaporates, returns as rain, and flows back again, while most of the dissolved salts remain in the ocean. Over billions of years, this continuous cycle has gradually built up the ocean's salinity. But rivers aren't the only source. Deep beneath the ocean floor lies another hidden mineral factory. Far below the surface, where sunlight never reaches, thousands of hydrothermal vents release superheated water from inside Earth's crust. Seawater seeps into cracks in the ocean floor, is heated by hot rocks and magma, dissolves minerals from the surrounding crust, and then rises back into the ocean, carrying those dissolved minerals. Together, rivers, hydrothermal vents, and volcanic activity have supplied Earth's oceans with dissolved minerals for billions of years. To understand just how much salt is in the oceans today, imagine removing every grain of salt from every ocean on Earth. If you spread it evenly across all the planet's dry land, it would form a layer roughly 500 feet, 150 meters, thick, about the height of a 40-story building. This salt does much more than make seawater taste salty. Ocean salinity helps drive global ocean circulation, influences Earth's climate, and provides the stable conditions that countless marine organisms depend on. So the next time you accidentally swallow a mouthful of seawater, remember, you're tasting minerals that have been carried from mountains, released from deep beneath the sea floor, and slowly accumulated over billions of years. If you learned something new today, hit that like button, leave a comment telling us what topic we should explore next, and don't forget to subscribe. Thanks for watching.